SwayamPrabha. Digital India. Educated India.
Okay, so welcome back. So this is we are starting now the third module of week 1. So we'll continue our discussion on the types of plastics which we were doing in the previous module, and I hope to complete that discussion in this particular module, and then we'll try to get into other topics. So far, if you remember what we have done, we have talked about what is plastic. We started looking at the types of plastic and also different types of classification of plastic based on usage, based on material. So to continue that discussion, so we talked about what is plastic. We also looked at, we are presently focused on types of plastic, and in this particular week we'll also look at the usage and global statistics, which will be in the next module. So this was the last slide that you were looking at in the previous module. So it's when we talk about plastic, you can have where you can look at from a heat perspective with respect to how it will react to heat. That's what the behavior. Then we also talked about the structure, then we talked about the physical chemical properties and types of resin. So that's where we stopped in the previous module. So to continue that discussion in terms of thermal behavior, when we talk about thermoplastics or thermoset plastic, it's a thermoplastics, it's a variety which softens by heat and hardens when cooled down. So if you apply heat to it, it will soften, it will become soft, and then when the heat is removed, when we cool it down, it will become hard again. So it can be used by remolding as any times as required. So that's what you can remold it and use it for different application. You can make different products out of that. So thermoplastics is that particular category. Thermosetting plastic, it cannot be reused. So that's so if we have more and more thermoplastics, actually it's better for recycling industry. Thermosetting plastic, it's very difficult, you cannot really reuse. This variety requires a great pressure and momentary heat during molding, which hardens on cooling. So you cannot really use it that easily. So it's essentially you can use it in a waste to energy. You can reuse it within the same product, but if you want to make new product after say molting this plastic out there, it doesn't work that way. So thermoplastics easy to recycle. Thermoset plastic better maybe for waste to energy plants. So that's what when we talk from the plastic waste management. So that's why these things are important when we were looking at into different options for plastic waste. So thermoplastic, it may melt before passing into a gaseous phase state, allow plastic deformation when it is heated. Chemical composition do not change, they are brittle and glossy, they are soluble in certain solvents, they swell in the presence of certain solvent, good resistance to creep. So it is can be remolded and made different products out of that from a thermoplastics. So it's highly recyclable. It's highly recyclable. You can have better finish because of the material property. You can have a superior finish, nicer finish, high impact resistance. You can remold, reshape. Its chemical resistance, it's a hard crystalline and rubber surface options. Both options are there. You can make it hard, you can make it soft. You can just play with the temperature, do the process. Eco-friendly manufacturing because you again can be recycled much easier. What are the drawbacks? It's more expensive, of course, because see, it is giving you so many options. Of course, it will be expensive. So it is more expensive than thermoset because and it can melt if heated. So if you are using it in a setting where things gets heated up, so it's if you are heating it and then it can melt. So it can be cannot be used in a scenario where it can potentially melt while in use. So that's where you need to be careful about that. What are the examples? We can polyethylene, polypropylene, polystyrene, acrylics, Teflon, polycarbonate, nylon, ABS, which is the acrylonitrile, butadiene, stearine. So all these different materials that you see, these are all thermoplastics. So this is what the thermoplastics we use for. thermosets. They are soluble in alcohol and certain organic solvents when they are in thermoplastic stage. This property is utilized for making paints and varnishes from these plastics. They undergo irreversible chemical process, they are durable, they are strong and hard. You can make beautiful colors. They are mainly used for engineering applications of plastics. So, most of the engineering applications that you see is mostly thermoset plastic, which is very difficult to recycle, but they are more resistant to high temperature. It will not melt. It will not melt than thermoplastic. It is highly flexible design. You can design it in different ways. A thick to thin wall capability. You can make it very thick, very thin. Excellent aesthetic. Again, it's some of the things are same. You can make nice looking at high levels of dimensional stability because it's again does not melt. So, even will not have effect of heat. Cost effective. It's relatively cheaper as compared to that. Problem with this, cannot be recycled. So, that is kind of a drawback. It cannot be recycled. More difficult for giving a good surface finish, cannot be remolded or reshaped. So, once you made it, that is it. Cannot really do many things with that. So, that is of course the drawbacks with that, but again at the same time it's both thermosets and thermoplastics both have different kind of applications as you saw for thermoplastic. Similarly, in the thermosets we use it for epoxy, polyurethane, unsaturated polyesters, phenolics, silicone. So, all those different applications that you have where the thermosets are used. Lot of for the construction application, for different machine parts where things may get really heated up, and so that is where thermoset plastics is most useful than thermoplastic. So, that is based on how its behavior against temperature. And if you if you remember the last slide from previous module and the first slide in the first module, this module which was the same where we are looking at the different types of classification. So, if we looked at classification based on behavior against temperature, now in this particular slide we are looking at classification based on their structure. So, based on the structure of the plastic. So, whether it is a homogeneous or heterogeneous. So, homogeneous plastic, these plastics are composed only of hydrocarbon atoms and they exhibit a homogeneous structure. So, what are those? Polyethylene, again polyethylene, polypropylene, polystyrene, they are homogeneous. Now, what is heterogeneous plastic? These plastics are composed of the chain containing carbon, hydrogen, oxygen, nitrogen and other elements, and they exhibit a heterogeneous structure. So, the structure is not homogeneous, there is it's a heterogeneous structure. Examples includes polytetrafluoroethylene, polyamides or nylons, polyvinyl chloride and then ABS. These are the heterogeneous plastics. So, this is a homogeneous versus heterogeneous plastic. And then if you look at from physical and chemical properties, there are rigid plastic which is very strong, like HDPE tubs, polypropylene cups, PET pallets, they are very rigid. And then you have semi rigid plastic which is LDPE films, flexible ducts where you can have ducts can move around a little bit, PVC sheets, so these are semi rigid. Then you have a soft plastic, children's toys. If you have looked at toys, those ducks and other stuff that is made out of plastic, those are soft plastic. Rattles, fishing baits, because fishing baits has to be soft, and then elastomers. Elastomers are polyisoprene, polybutadiene, polyisobutylene. So, those are like elastic plastic. So, it is a more elastic property. So, it is not at all, it is actually totally opposite to rigid. So, as we go from the left to right, we are seeing first rigid plastic, then the semi rigid, soft plastic and the elastomers. So, as you move along, you are looking at the elasticity of the material actually going up. So, it is becoming more and more flexible, and every different types of these different types of plastics have different applications as we know. So, rigid plastic will be the plastics which have high modulus of elasticity, as modulus of elasticity based on your strength of material codes. You know what is modulus of elasticity? It is the ratio of stress versus strain. So, stress will be on the top numerator, strain will be in the denominator, and we get stress divided by strain gets the modulus of elasticity. It basically tells us how strong, how rigid that material is. High modulus of elasticity, they retain their shape under exterior stress applied at normal and moderately increased temperature. Semi rigid, these plastics have medium modulus of elasticity, they can elongate under pressure and the elongation that is there under pressure completely disappears when the pressure is removed. So, it is kind of have little bit of plasticity there as well. So, you can apply some pressure, things will things may elongate, and once they take the pressure off, it will kind of try to come back to its original shape and size. Then soft plastic, this plastic has a very low modulus of elasticity and the elongation under pressure disappears slowly. So, you can you put if you elongate it under pressure and then you take the pressure off, you will have a slowly coming back to the normal shape and size. So, when so that is what the soft plastic is all about. And then you have elastomers, which is a soft and elastic material with very low modulus of elasticity. They deform considerably under load at room temperature and return to original shape when the load is released. So, the extensions can range up to 10 times their original dimension. So, think about the rubber band and all some of these stretchable things you can stretch, and once the pressure is removed, it kind of comes back to the original shape. So, those are your elastomers. As the name suggests, elasto means they are elastic. Elastic means which is which can be easily stretched, and then it tries to come back to its original shape when the pressure is taken off. Then we were talking about if you remember from the first slide of this particular module, we were looking at the different resin types, and I was telling you in the last module towards the end, I was trying to remind you about the number coding. So, that is what over here on this particular slide, we are looking at the number coding, where you have the code 1 which is a PET material, and then you have we have code 2 which is the HDPE. PET is the polyethylene tetraphthalate. Then we have HDPE, which is high density polyethylene material. We have PVCs, which is number 3. Number 4 is LDPE, which is low density polyethylene. Then PP, polypropylene. Number 6 is polystyrene, and then 7 is basically all other plastic, including polycarbonate, acrylic, liquid crystals, polymers, LCP, nylon, all those things together is our number 7. So, as we go from, if you look at from number 1 number 1 to number 7, as you go down the list, it becomes economically it becomes less and less incentive to recycle those. PET is the most recyclable material, easy to recycle, and economically it makes sense. HDPE is next, then the PVC, then LDPE, then PV and polystyrene. So, this number coding is very important when we look at the plastic waste, because when we will try to manage this plastic waste in a scientific way, one of the things we should look at, and we will probably have to look at in coming years or decades, is trying to separate this plastic based on this different code. Some countries they are already doing that, which when we try to separate PET, HDPE and PVC, LDPE, they try to separate those. At least PET and HDPE is separated from rest, because those two are easily recyclable and makes good value of economically it makes a lot of sense to recycle those as opposed to others. Sometimes PP, PS and other plastics, it is better to send it to a waste to energy plant. We will talk about that when we go into the waste management part of it, as opposed to trying to recycle this material. So, PET, what is that? We will try to in some of these material we will try to look at what is PET. It is this plastic is most commonly used on the planet right now. It took another, so introduced by J. Rex Weinfeld and James T. Dixon in 1940. This plastic is one of the most commonly used on the planet. It took another 30 years because it was used for crystal clear beverage bottle. So, in 1940 it kind of it was used quite a bit, such as the ones produced by Coca-Cola and Pepsi. So, initially the reason for that initially the plastic what they were trying to use the glass bottle. So, the beverage containers were mostly using the glass bottles, and when if I remember correctly, around 1969, 1970, at that particular time, it kind of makes sense, 1940 plus 30 is 1970. So, 1969 Coca-Cola did a study which we kind of refer to that in our LCA course, that Coca-Cola did a study where they looked at whether it's better to replace these glass bottles with plastic bottles for packaging of this beverage drink. Because they started making these plastic bottles, the PET bottles, and then it was lighter. Lighter means compared to glass, it was light material. Light material means it will be less heavy. Less heavy means less cost on transportation, and will help them to reduce the cost a little bit. So, that was the reason they were trying to go for plastic bottle. So, PET plastic now today kind of makes up 96% of all plastic bottles and container in US, and only 25% of those are actually getting recycled. So, when you think about plastic waste, of course, in India we have a bigger problem, but other countries are also not doing a very good job into plastic recycling. There are some countries which are doing wonderful job, but US, which we probably expect much better than 25%, if we can help in terms of recycling these code 1 plastic, actually we are helping into cleaner environment, less landfill pollution, and that's very much needed. So, it's a monomer of PET. PET is an excellent moisture and water barrier material. Its oxygen permeability is it's very low. It's kind of it's a lightweight. It's a semi-rigid, robust and impact resistance, and it's a hygroscopic in nature. So, that's kind of helps in its usage as different kind of applications where it is used. So, this is essentially that kind of gives you a monomer of PET. So, what we use it for PET is beverage container, water bottles, different types of containers for our food containers, some cleaning supplies, as you can see on this particular picture, and you will see that number 1 PET, that sign along with that as well. Here you see a picture of tomato ketchup right there, which if you can look at that particular picture over here, we have this tomato ketchup bottle. This tomato ketchup bottle is not only the PET material. It has the PET, but at the same time it has a layer in between as well. We are trying to we don't want the gas movement to trap the gas and moisture movement. It has a 2 layer of PET, and in between it has again a material in between which kind of keeps it our tomato ketchup fresh. And so, that's because many times when you buy those tomato ketchup, it will say almost its expiry date will be a year from them, a year or sometimes more from that particular date of manufacture. So, the reason to keep it fresh and nice, we have a layer of insulator kind of material in between, and then there is 1 PET, 2 PET, and with a layer in between, and that's how this plastic those bottles are made for ketchup and similar application. So, which is actually a mixed plastic, but more predominantly it is PET, but it's not 100% PET. So, that's what I wanted to point out to you. Then next more popular is HDPE. Again in 1953 it came about. You don't have to memorize many of these stuff like kind of put the name of the people and all that. I don't think we'll have questions along that line, but it's always better to have some general idea about when the plastic actually came into being. It's a most commonly recycled plastic because it's not break under exposure to extreme heat. According to EPA, only 12% of is recycled, which again it's a US data. The reason for that is in an Indian scenario, finding this data is also very difficult. So, we are trying to dig into the data and to find what percentage of PET is recycled, what percent of HDPE is recycled in India. We don't have those data easily available. So, again, those of you who are taking this course and have some information, as I said in the very beginning in the intro video of this course, there is no textbook on this particular course, and so when I decided to offer it, it was not only for it, it's a team learning. I want you guys to actively participate and bring some information, put it on the discussion board, which we can discuss. And so there might be, at the end of the course, I also want to learn much more about plastic waste than what I know as of today, because it will be a team effort, and where whatever you learn I will get, and whatever I know I will share with you. So let's share with each other and enrich our knowledge on plastic waste management and plastic in general, so that we can take care of this plastic pollution in the country and meet the goal of our which our Prime Minister already announced, that by 2022 we will not use any single use plastic. So that, and we will, of course, we need to cut down the usage of other plastic as well to reduce the plastic pollution from getting into the ocean, getting into the water, getting into our food chain. You may have heard recently there have been studies which has showed that many of the salt that without salt there cannot be any food, isn't it? Can you take a food like your regular meal without a pinch of salt? You need salt. If salt is not there by mistake, if we forget to add salt to our dal or our curries, it becomes tasteless. We need to add some salt to make it really taste good. And many of these salt varieties have been salt product which is available in the market, different brands, when tested had microplastics in them. So you and I don't want plastic in our body, because it can create different kind of disease. We also don't know what kind of disease it can create, because since it's a newer thing, but it is showing up in the food chain, it is showing up in the fish, it is showing up in salt. So those of you who think that, oh, I'm a vegetarian, this instructor is keep on talking about fish. I don't take fish. I don't stay in West Bengal. So West Bengal fishes are kind of our national food, but should not call it national food. But fish is essential in many of the meals. But it's kind of very common practice to have fish almost every day. But even if you are a vegetarian and you don't take fish at all, you cannot eat without salt, isn't it? You need some salt, and the salt microplastics are showing up there. So that's why we need to increase the recycling rate. We need to manage the plastic waste properly, and for that, if you find some information which is not being covered in this particular course, put it on the discussion board. We will like to have a good discussion on it, and of course we'll have some live session where we can, if you put something on discussion board, we can discuss it on the live session as well. So that will be really fun, and all will learn something new as we make progress in this particular course. So this is it, how the monomer of HDPE. So for each of the type, we have put this their structures and other stuff for you to look at, just to get an idea. The density ranges close to almost 1000 kg per meter cube. So 930 to 970 kg per meter cube. It is harder. It can withstand high temperature around 120 degrees centigrade. The physical properties can vary depending on the molding process. To make the specific sample is strong, and it's a dimensionally stable material. So that's why you see HDPE application in most of the study, like your buckets and your like big tumblers, big drums. You see mostly HDPE is used for those applications. In common application that mostly you will see for those kind of containers and milk bottle, your soap containers, soap, shampoo, and all those as mostly HDPE material. That again, you have to look at number 2. Whenever you look at these plastic, look at the number, and if it's number 2, it is HDPE. Polyvinyl chloride, it's the oldest synthetic material. It was actually discovered by accident in 1838 by one French physicist, Henri Victor Renault. And then again in 1872 by German scientist Eugen Boben. On both occasions they found it inside vinyl chloride flask left exposed to sunlight. So they had the vinyl chloride exposed to sunlight and they found it there. PVC is one of the least recycled material, generally less than 1% is recycled. It has been called the poison plastic because it contains numerous toxic and harmful to our health and the environment. So PVC is what we need to think about, like how to manage PVC plastic waste in a much better way, so that this tag of poison plastic it's not good. So we need to kind of think about how to manage that. PVC, most of the time it cannot be recycled very easily, so it can be reused, but it cannot be recycled very easily. So for that kind of material, having some sort of waste to energy process, another process does help, where you can use this PVC, again polyvinyl chloride, so it has a halogen. So you need to be really very careful in terms of when you use it for waste to energy. You need to have a very high temperature so that you don't have dioxins and furans being formed, which is formed in the presence of halogens. Halogens are, what are those halogens? Chloride, bromide, iodide, fluoride, those are called halogens halogen elements, which is it's there in one particular group of the periodic table, which we have learned about in our high school and other stuff. So this is like a polyvinyl chloride. It's a you kind of use the application of polyvinyl. You can use it for the laser application, you use for cables, for packaging, for pipes, for windows, for floorings. You have tensile roofs, you have medical applications. So PVCs are used a lot and recycled the least. So this is what needs our focus. Again, this makes our sense in terms of, if you are still wondering why our course is just still discussing about the type of plastic and all that, it's essential. It's because this kind of information is needed to make a good decision in terms of the plastic waste management. So these are kind of background information is needed. As I keep on saying that when we talk about any waste management or any plan that we make, we need to do a good diagnosis of the problem, and this is what we are trying to do. We are trying to get the background information so that we will have a good diagnosis of the problem. Then LDPE, it is the first polyethylene to be produced, making it the godfather of the material. It has less mass than HDPE, that is why it is considered separate material for recycling. Packaging and containers are made for LDPE, which is 50%, 56% of all plastic waste, 75% of which comes from residential household. So a lot of packaging material and containers are LDPE. So there are a lot of recycling programs to handle this product. This means less LDPE will end up in the landfill, and that's what we want, and that's the goal of the project of any good waste management system. LDPE, it's a very low density. Density is defined, then it can withstand temperature up to 80 degrees. It cannot. It is not reactive at room temperature except by strong oxidizing agent. So that's why it's used a lot of household application. It's strong and dimensionally stable material, high resilience, and that kind of shows you so this is the application. A lot of bags, you have different kind of containers, the thin containers, wrappers, and all those things, as you can see on this picture, they are mostly LDPE material, low density polyethylene material. Polypropylene, which is 3% of the polypropylene products are recycled in US. 350 million pounds were collected for recycling over a year, but a lot of this plastic is created, but only a small fraction is actually recycled. So that's what. So polypropylene, again, we have to. It's needed. It needs to be recycling, and better management practices needs to be looked into that. It's rigid, it's opaque, it's flexible, low density, it's electrical and abrasion resistance, good dimensional stability, excellent chemical resistance, weathering resistance. So that's and as you can see, the monomer, it is a C with a 2H, and then we have a CH3, which is like a methyl group is there as well. So that's on the polypropylene side, and you use it for different application, for the food containers, for some furnitures, from an industry application, in cosmetics, you have medicine and health. So different applications are there in terms of use of polypropylene in our day-to-day factor. Polystyrene or styrofoam, which is again 1839, accidentally came across that. They did some research on polymers. So polystyrene is very lightweight, and it can easily form into different plastic material, breaks effortlessly. It's more harmful for the environment. Beaches all over the world are littered with pieces of polystyrene. So it's endangering the health of marine animals. Polystyrene accounts for about 35% of the US landfill material. So these are essentially styrofoams. So again, as you can see, the monomer is different. It's a rigid, formed, clear, hard, inexpensive resin, easily processed, good abrasion resistance, transparent, and can be colored with different colors in there as well. So applications, you can see those single use containers, single use bowls, plates, which you and I many times uses in our for a party and other stuff. And when you go to a restaurant these days, they will give you the leftover, say they will ask you whether you want to take the leftover home, and they use these kind of stuff as well. So lot of polystyrene used, very poor recycling, and we see it basically getting into our oceans and water very easily. And so these were the all different 6 types, and then whatever is not included in these, we call it other and miscellaneous plastic. The remaining plastics are polycarbonate, polyactide, acrylic, like ABS, like acrylonitrile, butadiene, styrene, fiberglass, nylon. These are different types of plastics. There are different types of recycling program. Many of these plastics actually it's very difficult to recycle. Many BPA products like bisphenol A products fall into this category. It's best to avoid this plastic for food products. We don't want BPA in our food. It is not easy to break down this plastic. They are exposed to unless they are exposed to high temperature. So it becomes very, very difficult to them to recycle. So again, the stuff for the plastic we'll talk about in the plastic waste. We'll kind of talk about different methods of dealing with plastic waste. But the things that cannot be recycled, sometimes it's just easy for us to put it in a different treatment, like a thermal treatment could be an option. We are talking about plastic to oil. We are also talking about plastic roads. So those things can be used over there. So this is one example: polycarbonate, high temperature resistance, flame retardant, excellent clarity, UV resistance, and the glass-like material. Polyacrylites, again the structure is different. You have optical clarity, excellent outdoor material, good tensile strength. It can resist UV, easy handling, good impact resistance. Teflon, another chemically inert. Teflon, we use Teflon coated material, excellent lubricant, excellent dielectric properties, high bulk resistivity. Then polyamides, again high mechanical strength, thermal stability, tough at low temperature. So all the different types of plastics, variety of plastics are out there. Probably sometimes we don't even realize. ABS, flexible design, good surface quality, dimensional stability, brilliant gloss retention. Urethanes, easily foam, good bearing surface, good insulation. So these are all those different types of plastics which is out there. So we'll kind of for this in this particular module, what our goal was to look at different types, and that's what we have tried to do. And then in the next video, we'll start in the next module, that would be week 1, video number 3 is what we are completing now. So video number 4 will be the next one, and there we will start looking at the usage. So so far the first module was looking at what is plastic. And the second and third video, this is the last towards the end of the third video, we tried to look at what are the types. Now in the 4th and 5th video, we'll look at the uses and like different types of uses and some of the numbers, like what is how much plastic is produced globally, different types, and how much it's produced in India. So again, any question, feel free to put it in the discussion board, and we will be very happy to answer. And any suggestions, any feedback, do that as well. Thank you, and I'll see you again in the next video.